Okay. We're back in action. So let's get going. We're talking about the aggregate expenditure multiplier, and there was a little bit of unhappiness about how you rearrange an equation and do a partial write a partial differential. But so let's work through this. I said the aggregate expenditure equation at equilibrium we're going to have a situation where aggregate expenditure is equal to output, and our aggregate expenditure equation can be written as C plus I plus G plus X minus M. And we can write C as A plus BY, BY. Therefore, I can write this equation as Y is equal to A plus BY plus I plus G plus X minus M. Okay? We then did a bit of a rearrangement of this equation, and I think we were pretty confident that we could write this equation as Y is equal to 1 over 1 minus B times a whole bunch of variables again. A plus I plus G plus X, X minus M. Were we all happy with that? Did anyone have problems with that part? You with me? Okay. Then what I was trying to say is, if we change any one of these factors over here, okay, what is going to be the change over here? So you should be used to seeing the normal straight line equation y equals mx plus c. So if I were to draw this, I would have y, I would have x, I would have little c, okay, and the slope here, in other words, if I go from, well, I'll just write here, slope equals m. Are you happy with that setup? What does a slope equal to m mean? It means that if I change my values of x, so if I move from x giving me a value of, say, 1 to x giving me a value of, say, 2, then my value of y, when my value of x equals 1, okay, is going to be, right, it's going to be c plus m, and that's it, right? C plus m. Are you with me? At 2, what is my value of y when x equals 2? It's c plus 2m. Yes? So when I change the value of x by 1, okay, so change the value of x by 1, what is my change in the value of y? Change in the value of y is, I mean, like, I'm saying this stuff and I'm hearing nothing as if what I'm speaking is absolutely new to you, like you've never seen maths like this before in your life. Are you with me or not? It's like this is literally maximum standard 8 stuff that you saw this for the first time. Whatever, grade 12. No, grade 10. Sorry, grade 10. Are you with me on a straight line graph? That if I have y equals mx plus c, if I change the value of x by the value of 1, I change the value of y by the value m. Yeah? Okay, and the way that we would normally write this story is to say given this equation, I can write the derivative of this equation as change in y over change in x is equal to m. Okay? But obviously I'm saying change in y is m over change in x is 1, which is just m. Okay? Cool. Now, if I wrote this equation, instead of saying y equals mx plus c, if I had y equals mx, okay, so there's no c. So, no c. Y equals mx, okay? If I change x by the value of 1, what am I changing m, the value of? I mean, sorry, what am I talking about? If I change the value of x by 1, by what value do I change y? What's the change in y? If my change in x was 1 in this new equation. It's m. I don't know if your silence means you have no idea what I'm talking about, or if it's just so boring you wish I would shut up. What are we talking about here? Do you know what I'm talking about or not? Yes. Okay. So change in y over change in x equals m. It doesn't matter whether there's a c or not. The change in y given a change in x is just going to be m, regardless of the c. Okay? Now if I wrote this equation instead of y equals mx, I mean, let's say, so I've got the same equation, but now what I want to do is I want to say x is equal to w plus z. Okay? Are you happy now that my equation would be y equals m w plus z? Are we still on the same page? Okay. Now, if I change z, change in z equals 1. Okay? What is my change in x going to be? If I change z, and I tell you that the change in z is going to be 1, what is my change in x going to be? Okay, let me write this slightly differently. Maybe it'll make it even more. X equals w plus little d times z. Okay? Now, I'm going to tell you that y is equal to m times w plus little d times z. Okay? Now, if I change x, what is my change in y? If I change x by 1, what is my, sorry, not change y, what am I talking about? I'm getting myself flustered here. Change in z equals 1, what is my change in x? Okay, let's go back to basics. If I have y equals mx plus c, if I change y by the y of 1, what is my change in x? M. If I have x equals w plus dz, I change z by 1, what is my change in x? Wow, guys, we got some serious introspection to do here, right? Here's my equation. Does this equation here not look suspiciously like this? X equals dz plus w. So if I change my z by some amount, my change in x is going to be d. Like, okay? Good. So I change z, I get a change in x of d. Okay. Now let's make the value of d 1. So when I change z by 1, what is my change in x going to be? 1. Okay? So when I change z by 1, my change in x is 1. Okay? Whew. When I change x by 1, I change y by m. So if I change z by 1, I change x by 1, I change y by how much? M times 1. M. So change in y divided by change in z is just m. Did we step through that in a way that made sense? So if I change y, if I change z, I change y by m. Okay, now we're going to just, I don't know what we're going to do here. We'll see how this goes. Okay. Y is equal to mx. Yeah? You happy that equation is the same? Okay. Now I'm going to change x by the value 100. Okay. If I change x, so change x equals 100. Okay. What is the change in y going to be? M times change x, which is 100. Okay? We all with me? So if I change I by 100, what is the change in y? Change in I, 100. What's my change in y? 1 over 1 minus b times the change in I, which is 100. So it's 100 times 1 over 1 minus b. Okay? Everyone with me? So what have we just described? What have we spoken about? We've changed aggregate expenditure by some amount. We've changed aggregate expenditure by some small amount. And by how much does y change? It changes by the amount of aggregate expenditure multiplied by 1 over 1 minus b, by some factor. This factor, this thing here, this factor is called the multiplier. It's called the multiplier because it's the thing by which we multiply the change in y. So this is the aggregate expenditure multiplier. What is the value of b? Is it greater than 1 or less than 1? B. It's less than 1. It's greater than 0, but it's less than 1. So if b is less than 1, what is 1 minus b? Greater than 1 or less than 1? It's also going to be less than 1. And then what is 1 divided by some number that is less than 1? Is it less than 1 or greater than 1? It's greater than 1. Okay, we're back on our maths game, right? The multiplier is greater than 1. Are you happy with that? The aggregate expenditure multiplier, it is greater than 1. Why is it greater than 1? Because the value of b is less than 1. Yeah? How did we get this multiplier? Well, we said at equilibrium, we just rearranged this equation to have y. Instead of on both sides of the equation, we just rearranged to have y by itself on the left. Yeah? So that if we change anything in any of the aggregate expenditure components, we know what the change in y will be. Yeah? We change aggregate expenditure by some amount. Okay, so change in I, for example, our change in y is going to be that coefficient times the change in I. Why? Well, because we've seen that that's how the maths works. Okay? And it doesn't matter how many little, it doesn't matter how many, oh my goodness. Okay, here we go. It doesn't matter how many variables we have over here. Okay? Same as, it doesn't matter how many variables we have over here. The procedure is the same. Everything works the same. So if we zoom out a little bit, yeah. Which one? The green. Where there's a what? Oh, here, this one here. Yeah? Okay, excellent question. Let's first make sure everyone's happy with this, and then we'll go nuclear. Okay? Is everyone happy with the aggregate expenditure multiplier there? With what we've done there? How we did it? Why it works? Is the maths complicated? No, there's nothing complicated about the maths, okay? The economics isn't complicated either, okay? So just spend some time just practicing it. There's nothing complicated here. Practice it. Just be like, okay, yes, I know what I'm doing here. There's nothing difficult, okay? I change aggregate expenditure. I change output. There's a multiplier effect, okay? What I did in this equation, I'm going to zoom back in again. I've had a request to change some things up. So in this equation, what I assumed, what I assumed in this equation, you'll notice that taxes are 0, and I said little m was 0 as well. Okay? So there was no autonomous stuff. I mean, there was no autonomous taxes, and there was no induced import effect. Okay? Now remember, taxes, we can have two different types of taxes. We can have a lump sum tax, which is just capital T equals 100. Lump sum. Okay? Or we can have a tax rate. Tax rate, which says capital T is equal to little t times y. Okay? In other words, an income tax rate. Your tax that you pay is determined by your income. Okay? This is the kind of tax rate we would normally deal with. Sorry, when I say normally. What you would normally encounter in the world is a tax rate. What is VAT? VAT is 14%. It's a tax rate. Income tax. What is the income tax rate? Depends what you earn, right? But anything from 0% to, I don't know actually what the top is. It's like close to 60%, right? So what we assumed was just that taxes equal 0. So this was our assumption. I'm going to say initial, first I'm going to just reorganize my life here a little bit. Okay, so in our equation we've assumed that t equals 0 and little m equals 0. Now we're going to change that. I'm just trying to think about best way to do this. Okay, so we've been through all this equation here. Okay, now we're going to assume something different. Now we assume that taxes are given by some tax rate, and imports are given by some marginal propensity to import. And now we write at equilibrium. At equilibrium, we have our equation where output y is equal to aggregate expenditure, where aggregate expenditure is equal to C, and C is equal to A plus B times y minus taxes, and taxes are TY. With me? Okay, plus investment, plus government spending, plus exports minus, and again, our imports are MY. Okay? Calculate the multiplier, go for it. Can I ask you for the answer here? If we have y equals a plus by, y minus t, y plus I plus g plus x minus my, if I were to rewrite this just to have y on the left-hand side, y is equal to, what do I end up with? 1 over, yeah? 1 minus b plus bt plus small little m times Does that look right? You happy with that? Does that correspond to what you've done? At the end of chapter 27 in the appendix, they have exactly the same rearrangement. It's on page 623. 620, even before that. 621, beginning of the appendix. So they do the calculation in page 621. Any problems with that calculation? Are you happy that it's relatively straightforward? It's just, rearranging some numbers to solve an equation. Okay, so what do we call this thing over here? The multiplier. When we added a tax rate and we added a marginal propensity to import, okay, how did we change the value of the multiplier? Are you happy that when we added this marginal tax rate and we added this marginal propensity to import, right, we made this number at the bottom here bigger. If we make this number here bigger, we are making the multiplier itself smaller, right? So when we added a tax rate and a marginal propensity to import, our multiplier was made smaller. Yeah? Why is the multiplier smaller? Because there are leakages. Instead of now consuming, remember that we have a marginal propensity to import. When we get our income, we would then consume it. Now we get our income, we pay taxes, then we consume it. Right? So you can see that the multiplier is going to be reduced because first we have to pay taxes. Secondly, we have a marginal propensity to import, which means our income goes up. Then instead of just spending all our income on goods and services in our own economy, we spend some of it on goods and services in other economies. So the multiplier is made smaller, it's reduced. Yeah? Because there are now leakages in the system, reducing the multiplier. So our multiplier effect is reduced once we add a marginal tax rate and once we add a marginal propensity to import. And in fact, if we add any other kind of leakage, it's going to reduce the multiplier effect. So I will put all of that on I will save this PDF, just make it look a little bit nicer and put it on Sakai. Okay, so those notes today will be on Sakai. Okay, now that we've had that little interlude, we can go back to where we were. We have a multiplier, and the size of the multiplier. To calculate the multiplier, we divide the change in equilibrium expenditure by the change in autonomous expenditure. Okay? So we increased expenditure by some amount, 100. We increased output by 600. What is the multiplier? The multiplier is 6. Are you with me? Sorry, in our previous example, if we increased aggregate expenditure by 100 and it increased output by 600, then our multiplier is, because here's our equilibrium values, our multiplier is 6. Okay? So now to get the value of b, you would have, the multiplier is 1 over 1 minus b. So 6 is equal to 1 over 1 minus b, right? In which case you should, as I say, get b to be 5 over 6. Sorry, the reason that I messed this calculation up, which was completely stupid of me in the first place, was I took a change in AE, this change in AE, and this change in Y, as if it was along the same curve. Which is not, which is why my calculation of 1 over 6 is obviously incorrect, right? the actual number is 5 over 6. So, if the slope of our aggregate expenditure curve, the magnitude of the multiplier depends on the slope of the aggregate expenditure curve. If the slope of the aggregate expenditure curve, right, is 0.75, then the multiplier is going to be 4. 1 over 1 minus 0.75. If the slope of the aggregate expenditure curve is 0.5, then the multiplier is going to be 2. Everyone happy with that? We've seen what happens when you add imports and when you add taxes. Had some more examples, and then we're going to derive the aggregate demand curves. So, yeah, let's just do another example. So, let's cement this in our brains. We've got 2 questions here. Use this information to answer questions 23 and 24. Equilibrium level of GDP. Equilibrium level of GDP. How do we calculate equilibrium level of GDP? Well, we know at equilibrium, Y is equal to, or output is equal to aggregate expenditure. Income is equal to aggregate expenditure. So what's aggregate expenditure? C plus I plus G plus X minus M. No X or M, so that makes our life easy. Which means at equilibrium, Y is equal to C plus I plus G. Great. No X and M's. What is C? C is A plus B times YD. What is YD? Y minus taxes. Okay, minus T. Y minus T. Great. So, can we now start filling some stuff in here? Y is equal to A. What's A? 1,000. Plus B is 0.75. Times Y minus taxes, which is 1,000. Minus 0.5Y. Plus I, what is the value of I? It's 200. What is the value of G? 3,000 plus 3,000. Okay, so Y is equal to, so I can now say Y. I can either rearrange it, or I can just, in other words, I can rearrange it to say Y minus, and then calculate the multiplier, and then calculate the autonomous components, or I can just work the multiplier into my calculation now. What I'm going to do is I'm going to calculate the multiplier because question 24 says what is the multiplier. So I'm going to kill 2 birds with 1 stone here, and I'm going to say Y is equal to, and first I'm going to get my autonomous components here. I've got 1,000 plus 0.75 minus that, so it's minus 750, okay, plus 200 plus 3,000, and then I've still got my induced components, so then it's plus 0.75y, okay, and I've got plus 0.75 being times minus 0.5, which is minus 0.375y, okay. So what is my multiplier going to be? If I've got y there, I've got y minus 0.75, y minus 0.75y minus 0.375y equal to this whole inside bit there, which is, if you add all that stuff together, what do you get? 3,000? No, 4,000, right? Sorry. Is that right? Oh, sorry. Yeah. Like that. Cool. And then 3,450, is that right? Okay. So what have I got here? Y times 1 minus 0.75 plus 0.375 equal to 3,450. Okay, so then I've got y equal to 1 over, what is this number here? Something horrible that I don't want to calculate in my head. What is it? Sorry? 0.625 times 340.